All right, here is try it 4.4 from PreCalculus OpenStax. Essentially what's going on in this problem right here is you are given two data points and told that you have an exponential function and told to come up with that function. And it actually goes a step further. There's two flavors of that type of problem that I just described, an easy type and a hard type. And the easy type is one when they tell you when one of those two data points has an x-coordinate of 0. And in fact, that's what's going to end up happening here. The hard type is when neither of your two data points has an x-coordinate of 0, and I'll deal with those when those arise. So in this one, we're told a wolf population is growing exponentially. That's important. We know it's an exponential function. And then we're told in 2011, 129 wolves were counted. By 2013, the population had reached 236 wolves. They want you to know what 2 points can be used to derive an exponential equation modeling this situation. Write the equation representing the population of wolves over time t. The trick to this problem is recognizing that you can make 2011 represent t equals 0. So I can say that this information right here corresponds to the point 0, 129. And 2013, the rest of this information here, this and this, tells me that 2 years later, I have 236 wolves. And you're like, whoa, how can you just do that? Shouldn't this x-coordinate have been 2011 and this x-coordinate have been 2013? Well, yes, if x represents the year, or t represents the year, I suppose, but there's no reason t has to represent the year. We can just say, let t represent number of years after 2011. And if that's how we define t, then t equals 0 here, and t equals 2 here. And now that you have these two data points, you can take it a little bit further, but actually when I'm rereading this, I don't think it asks you to. It just asks what 2 points can be used to derive an exponential equation modeling this situation. Oh, and then it does ask you to write the equation. Okay, so we can do this. This right here is telling me that when the x-coordinate, t in this case equals 0, the y-coordinate is equal to 129. Well, that's exactly the y-intercept. This point right here tells me that the a in y equals a times b to the t power, I guess, is equal to 129. So then all I got to do is figure out what b is equal to. Well, I can do that by using this point. I can say when I put 2 into this machine, 236 comes out. So I know that, where am I going here? Maybe up here. I got y is equal to a times b raised up to the t power, and this point, that's kind of weird, tells me that when y equals 236, t must have been equal to 2. So I get this equation right here. And so I can solve this equation. I don't think this is going to work out too nicely, unfortunately. I guess I'd divide both sides by 129. So I'd get 236 over 129 is equal to b squared. And therefore b is equal to plus or minus the square root of 236 over 129. Wait a minute, I just heard you say plus or minus. How come you didn't write plus or minus? Think about that. That's important. When you decide to take the square root of both sides of an equation algebraically, it is important, it is imperative, it is very, very important that you put in a plus or minus. Because there are two different numbers that when I square them give me this. One is a positive number, one is a negative number. A negative number times a negative number gives me a positive number. So why didn't I write it then? Well, remember our restrictions on b, right? B has to be a positive number not equal to 1. If I put in the plus or minus, I'd be saying b could be a positive number or a negative number. That's not the case. This is the only value that b can be equal to. Can you simplify this? I don't know if you can or not. I'm not going to bother. Throw it into a calculator if you feel like it, but then you'll just get a decimal approximation most likely, unless this simplifies really nicely in some way that I can't see. I don't think it does. Now I'm curious if it does or not. Well, whatever. That's not the point. I'm just going to call this b. So I'm going to say y is equal to a times b raised up to the t power, and call this my answer. And remember, in this situation, t represents the number of years after 2011. If I don't make that declaration, then this doesn't make any sense. What the hell is your variable here? What's t? You have to kind of let the reader know.